Good afternoon, students. Welcome back to STEM Block Down Digital School. My name is Gratian Chimanda, and I'm your mathematics grade 12 teacher. So this week, all week, we've been doing trigonometry. We've learned about double angles. We've learned about compound angles, and we have learned on how to solve equations using the quadratic. Not quadratic, using the compound and double angles. Sometimes they involve also algebra, like the quadratic equation, where you have to solve it as a quadratic equation. We have also learned about the general solutions of the three trigonometric ratios, which is the sine, the tan, and the cos. We have also learned on how to represent them on their graphs, and how to find as many solutions as we can in a particular range, which is very crucial, so that you will be able to find all the required solutions that are given. So I think this will be our last day doing trigonometric. And next week you go to calculus. But today I just decided to dedicate this lesson to question and answers. Yesterday I gave you homework. I'm just gonna quickly go to it right now. I gave you homework, or I gave you questions to do that you can do. So I'm just gonna quickly go to it. So in the question and answer segment, or like question, live, you can post if you have any questions that you want us to do, or if there's something that you don't understand, or if we realize that there's a mistake somewhere. We are in this together, so let's do it together. So I'm just going to quickly share a screen that I would want. This one, are you able to see? This one. So we're going to do these questions together, right, to find the general solution. So exactly let's do number 7. We did number 3 yesterday, number 5. So we're going to do number 5, because we did number 4 yesterday. So we're going to do number 5, let's say number 6 and number 7. And I also have some questions on my side, on the textbook that I have here, that we are going to use to do. So I'm quickly going to write number 1, which says find the general solution. So it says find the general solution for sine x cos 3x plus cos x sine 3x is equal to tan 140 degrees. So we want to find the general solution, that is number 5a, right? So illustrate on the solution. So it says illustrate, illustrate the solution. Remember, this is the Siavola textbook that we can access freely online. So you don't have to worry about buying one, you just have to go and download. Right, numbers, I'm going to write number 7, because number 7 is a little bit shorter. So it says solve for x. Solve for x, where is the equation is square root of 3 sine x plus cos x is equal to 2. So in this case, we're not given an interval. So what does that mean? It means that we're just going to find the general solution. So we have 2 questions that I've written down. So I'm going to go back, and we'll be doing that more often. So I'm going to stop sharing. So we have our 2 questions, right? Question number 5 and question number 7 from exercise. Let me just quickly check. It's from exercise 4. exercise 4. So those are the 3 questions that we're going to be doing. So let's start with question number 7, which is number 7. So we're starting with question number 7. Question number 7 says square root of 3 sine. Okay, let's start with number 5. So we start with number 5. So find the general solution for this. So with this one, what do? We want to find the general solution. So it's written sine x cos 3x plus cos x sine x is equal to tan 140 degrees. So now let's come here now and check what is sine x cos 3. So sine x cos 3x, right? And I've got cos x sine 3x. But I know this is quite familiar to an identity that I know. So the identity says if I have sine A plus B, it is equal to sine A cos B plus, so it's sine A cos B plus cos A sine B. So I can actually see that in this case, my A is my x and my B is my 3x. So I can move from there and write it backwards. Right? So I'm going to write it backwards. So this becomes sine x plus 3x. Because my A is x and my B is 3x, is equal to tan 140. So this becomes sine 4x is equal to tan 140. But now we must convert what is tan 140. Because tan 140, we can easily find what is its value. So we can come and say tan 140 is equal, so we get a value which is equals to negative 0.839. I'm going to say negative 0.839. So in this case now, if I'm here now, I'm going to say shift sign. This. So shift sign, so shift sign the answer, because I'm now doing this answer, which is 0. I'm just saying shift sign. So 4x is equal to shift sign 0.839. So 4x is equal to minus 57.045 degrees. Right? So now, what can I do now? I'm going to, so this is what my shift sign, this is my 4x. So now, I can now go in and say my general solution is 4x is equal to negative 57.045 plus k times what? Times 360. Oh, 4x is equal to 180, because do you remember the general solution for sine? Minus 57.045 plus k times 360. But this is 4x. Remember, this is what? This is 4x. So the general solution is I'm going to divide everything here by what? By 4. So I'm going to divide everything by 4. So x is equal to, so what is this divided by 4? It's negative 57.045 divided by 4. I get is equals to negative 14.26125 plus k. What is plus k? Was 360 divided by 4 is 90. So I may find my general solution. Or in this case, it's, remember, it's 180 because our general solution. So it's 180 minus 57 57.045, which is equal to 237. Then I divide by 4. I'll get 59, which is equal to 59.26125 plus k times 90. These are my two general solutions, because I divide this one by 4, because I'm going to divide everywhere by 4, and I divide this one by 4, I get my general solution. So with this one, very simple, not a problem. Let's go to another one. I'm going to quickly write another one, and we're going to do together again. It says solve for theta between negative 180, 180. So it's sine for theta is equal to cos to theta. So we are going to solve this for theta is between negative 180 and positive 180. So now let's go. You say sine 4 theta. Since this is 4 theta, I can now write the sine 2 factor of 2 theta is equal to cos 2 theta. I have the identity for sine 2 theta. We all know the identity. Okay. Someone is asking, let's go to our general solution and quickly check our general solutions. I want to quickly share. Let's quickly check our general solutions. We're just following our general solutions. Here is our general solution. So I want to go back to our general solution. Here, the general solution says it's shift, the one that you get, shift sine x plus k times 360, which is this one. And it all is 180 minus whatever you get shift here plus k times 360. So these are the two formulas that we used to get our general solutions, because now everywhere we divided by 4. So this is 180 minus whatever shift sign we got plus k times 360. Let's quickly, I'm going to quickly go back. I hope you've seen that one. So let's quickly write our solution, our identities. It says sine 2a is equal to 2 sine a cos a, and cos 2a is equal to, it's either you're going to write it as sine cos squared a minus sine squared a, or you can write it as 2 cos squared a minus 1, or you can write it as 1 minus 2 sine squared a. So in this case, for sine, I'm going to use, because we only have one identity. So this becomes 2 sine 2 theta cos 2 theta is equal to cos 2 theta. So with this one, it is easier now. Remember, I said I can easily divide by cos 2 theta here. If I divide by cos 2 theta, then it means I'm going to lose some of the solutions. So the best thing is to factor it out. So I'll write 2 sine 2 theta cos 2 theta minus cos 2 theta is equal to 0. That is the first thing that I do. Then I factor it out. If I factor it out, I'll get cos 2 theta factor of 2 sine 2 theta minus 1 is equal to 0. Right? So you actually see that now I have cos 2 theta is equal to 0, or 2 sine 2 theta minus 1 is equal to 0. Now I can now find solutions one by one. So here 2 theta is equal to shift cos 0. Oh, here I will say I'll first make sine 2 theta the subject of the formula. So it says sine 2 theta is equal to 1 over 2. Therefore, 2 theta is equal to shift sine half. So with this case, 2 theta, what gives us 0? It's if shift cos 0. Shift cos 0, you can first find the principal value using your calculator, or if you know. So shift cos 0 is 90 degrees. And we also have 270. So someone says, say I'm never sure which identity to use. Okay. On this one, look what we've done. We've only used one identity. We used one because the moment I introduced this identity, right? The moment I introduced this identity here, I could actually see that everything now is in the form sine 2 theta, cos 2 theta, and cos 2 theta, which means I can now factor out cos 2 theta. In this one, I don't have to expand it anymore because I can simplify and shift and get my 2 theta, my answer quickly. So for you to be sure, it needs you to do more practice on trying which identity to use. Sometimes you, by practicing more, you will automatically get to a point where you'll be able to realize which identity must I use. Right? So here is 270. Right. So we want to find between and 180. So now I can divide now this. So theta is equal to 45, and theta is equal to, if I divide 270 divided by 2, I get 135. So I have two solutions, one solution and another solution. And here now it's shift sine half. Shift sine half, I can come and shift sine 1 over 2. Shift sine 1 over 2 is equal to 30 degrees. And the next one is 150 degrees. Why didn't we use the identity for cos what's the name? Cos 2a? I did not use the identity for cos 2a here because I immediately realized that I can put the cos 2a cos 2 theta on this side. If I put like I did, I moved it. When I expanded this one, it gives me 2 sine 2 theta cos 2 theta is equals to cos 2 theta. So I immediately realized that if I take this cos 2 theta and put it on the other side, I can easily factorize cos 2 theta and come outside. Then now I can now say cos 2 theta is equals to 0. And so for me now to introduce this, it will still I can still get the answer. I can still get an answer. I can show you just now that I'll get 45 and I'll get 45 and 135, or I will still get 30 and 150. So with let me quickly finish this one, then I can show you just now. So now I have 150 and so this is cost 2 theta, 150 and 30. Now I'll also go to another one because I know that if I divide 30, I will get 15 for this one, and here I'll get 75. But is it the only one? Should I get another one here that if I divide by 2, it is within the range of 100. So it will be what? It will be 30 plus 360 divided by 2. It is 195, which is not within the range. How did you get 150? Not a problem. Okay. There are so many ways to get 150. If you know let me show you another way. If you know your graph, if you know your graph for sine, I'm gonna quickly draw it here. You must learn these graphs. They alternate between 1 and -1. So this is the graph of sine theta. This is the graph of sine what? Of sine theta. Let's just say sine x so that we don't confuse it with this theta. There's the graph of sine x. So if I say half, let's say half is here, because half is between 0 and 1. So I want to draw. Well, this is 180 and this is 360. So if I check, it cuts to 2 points. Here, it is 30 degrees, which you are given as the principal value. And here now, how do you get? Because now I say this area is similar to this small portion. So how do I get this? It's 180 minus this portion, we can see that is 30. So it's 180 minus 30, which is 150. Or you can use let's come here, or you can use the general formula, which is here. It says the general formula, we use the second one, which is 180 minus sine plus k times 360. This one. So you're going to come here now and say the first one is k, or your k is 0. So it's 180 minus 30 plus 0 times 360. If we get this one, we get 150. All right? You get what? You get 150. Someone is asking, where did you get 195? Okay, it's fine. If we use the first one, which says the first one says 30. Let me just quickly write it down so that we can revert back to it. It says theta is equal to shift sine x plus k times 360. I'm gonna go back. This one. I'm gonna go back. I'm gonna stop sharing the screen. Now, where did we get 195 from? So if I take 30 that I got here, I say 30 plus, if I put a 1 where there's k, it becomes 360, which is equals to 390. So I'm saying my 2 theta is equals to 390. If I divide, so 2 theta is equals to 390. If I divide by 2, I get theta is equals to 195, which I said it is not within our what? Within our range. I was just trying to show you that you stop at 150, because the moment you go ahead, it becomes wrong. So that's why I put 195 and I put an X here to show that it is not within our range. What we want is 1, 2, 3, 4, 5. We have 6 solutions that will help us. We can also use our calculators. Yes, you can use your calculators, table mode. Normally, I just put my calculators in degrees. If my calculators are in degrees, then I am sorted. So I hope you have understood these questions or how to find the solutions and solve. Right. I think this is now. Let's go to another question. Let's do something that involves tan. It says tan 2 theta is equal to 2 tan theta. Right? 2 tan theta. So I'll just come back here. If it's, let me explain here. So I found my solution, but if you're just asked to find the general solution, you just have to write it in this format. If they just ask you to, because this is the general solution is the one that enables you to find the particular solution. So it depends on the question. Now let's go to 2 tan 2 theta is equals to 2 tan theta. So we know the identity for tan 2a is equal to 2 tan a over 1 minus tan squared a. That is the formula. So this one now is becomes, so we just replace this one. So this becomes 2 tan theta over 1 minus tan squared theta is equal to 2 tan theta. I've simply expressed. So the question says also find between 0, negative 180, and theta and 180. So this brings me back to what we have solved, right? Okay, that's fine. So with this one, I hope we all know how the graph of tan looks like. The graph of tan looks like. They are sort of asymptotes about within the range of 180. I'm just going to quickly draw them so that you can familiarize with them. They are very important, but so it's 90 and we have negative 90 here. And so you draw a line at 90 and you draw a line at negative 90, right? So there's 180 and we have 270 here. You can also draw the asymptote and also that side. So the graph of tan looks like this. They're sort of asymptote. That's why we say if we find a point here, so if we are looking both, now the graph of tan is ungoverned. It goes to negative, it goes to positive infinity and negative infinity here. But it does not touch the line of 90. If you go on your calculator and if you punch tan 90, you will get an error. Tan 90, you will get an error because it's undefined. So it does not touch the line 90, does not touch the line 270, does not touch the line. So that's why if you say, if we want to find the solution, we draw a line. Let me use another pen. We draw a line. So you can see that it passes through, it cuts here and cuts here. So that's why we always say we must add 180 degrees because between this point and this point, is 180 degrees. Just like here from this point to this point is 180 degrees. So that's why we say whatever we find shift tan, we must always add 180, because between the 2 points on the same, let's say this is 1. So if here we get 45 degrees, here it will be 45 plus 180, which is 225 degrees, right? Which is 225 degrees. So that's why you see we are adding 180, and we also add 180, 180, and even here we subtract 180, 180, going forward and backwards. Can we use this tan identity in our exams? Yes, if the tan identity, yes, we can use it in your exams, right? So we cross multiply. So 2 tan, it's the double angle identity. It's the double angle identity, so it is irrelevant. So 2 tan theta is equal to 2 tan theta factor of 1 minus tan squared theta. I've just cross multiplied. Cross multiply. So in this case, it's factored, or I can check. So in our example, we would have 6 values for theta. In this example, let's see. So I can say 1. I'm just writing this in the reverse, tan squared theta, then 2 tan theta minus, because I'm taking this to this side, 2 tan theta is equal to 0. All right. Then I can factor out 2 tan theta. So 2 tan theta factor of 1 minus tan squared theta is equal to 0. Because I have sorry, let me see. 2 tan, I'm left with this one, and here it's minus 1. Sorry, minus 1 is equal to 0. Because in this case, I've taken out 2 tan theta. Then I'm left with this minus 1, because when I took out 2 tan theta, I'm left with 1 here. So it becomes 2 tan theta is equal to 0. Or in this case, I have this one, and this one becomes also 0. So it becomes tan squared theta is equal to 0. Let me just check if we did not make a mistake. Or we can easily expand it if you are not sure, right? We can easily expand. So this becomes 2 tan theta is equal to 2 tan theta minus 2 tan to the power 3 theta. So this one and this one, they cancel out each other. They can subtract each other. So we have tan to the power 3 theta is equal to 0. So tan theta is equals to 0. So which values gives you 0, right? We have 0. We have 0. So theta is equal to 0 is equals to 180, and is equal to also to negative 180 degrees. These are the 3 values that we get. So theta is not difficult. Tan is not difficult because it's just merely adding 180 and subtracting 180. We want to look for another one, which is a little bit challenging. Then we will be able to. Let's quickly do another one together. I want to do something that involves the double angle. It says 2 sine theta is equal to 3 cos theta minus 60 degrees. And you are going to solve it between 0 less than x less than 180. Or we can just give it as a general solution. So with this one, 2 sine theta, but we have a double angle here. So if we can write it as 2 sine theta is equal to, so this 3, I can write it outside, and I can expand this as my identity. So the identity for cos, or the double angle for cos, it says cos A plus, minus B is equal to cos A cos B plus sine A sine B. So here I can now come and say this is equal to cos theta cos 60 plus sine theta sine 60. I've converted this using the double angle, compound angle formula, or common angle identity. So 2 sine theta is equal. So what is cos 60? We can go onto our calculator and punch cos 60. So cos 60 is equal to half. So this becomes 3 times half, which is 3 over 2, cos 60, cos theta. And here, what is sine 60? Sine 60 is equals to root 3 over 2. Is equals to root 3 over 2. So plus 3 root 3 over 2. I've multiplied this 3 times 3 times 3 over root 3 over 2. So it becomes 3 root 3 over 2 sine theta. Because so the another problem that might happen is that you might forget to multiply this into 3 into there. So the moment you forget to do that, it becomes wrong. Or you can first divide by 3, and the 3, it becomes 2 over 3 here. Then you can expand. Me, I decided to multiply it in. So now I can take this to this side. It becomes 2 sine theta minus root 3 root 3 over 2 sine theta. Why am I taking to this side? Because it is what's the name? It is the same variable, sine theta and sine theta, so I'm putting them and grouping them together on one side. Is equals to 3 over 2 cos theta. Now I can add these two, because since they're the same, I can add their coefficients. So now I'm going to add their coefficients. Is 2 minus root 3 over 2. I get 4 negative 3 root 3 over 2 sine theta is equal to 3 over 2 cos theta. The next step, since I have two variables, sine and cos, I want just to remain with one value, with one variable. So we are all familiar with this, which says tan A, the identity is equal to sine A over cos A. That is the identity that we get, that we know already. So I can divide everywhere by cos theta and everywhere by cos theta. I mean, this cancels this one. So here I'm left with negative 4, 3 root 3 over 2, because sine theta over cos theta is tan theta. So tan theta is equals to 3 over 2. Because the cos has disappeared because it has cancelled out. Right? Now I divide everywhere by this, which is 4, 3 root 3 over 2. This cancels this one, and here 4 minus 3 root 3 over 2. So notice that we are right. I'm writing this in exact form, right? Because if I try to put it in decimal format and divide, somehow I'll have some small error in my degrees. Why? Because it's not exact, because you would have rounded off. either to 3 significant figures, or you would have rounded off to some particular decimal place. But in this case, I'm just using exact figures. So that now I can write tan theta is equal. So I'm going to divide this by this. So it's 3/2 divided by 4 minus 3√3/2. I can now put this in decimal, which is negative 2.51. Let me say 2.5, negative 2.51. I hope you also get the same. I hope we are also doing this together. So I can explain from the top a little bit before we get it, because the moment we get here, we can find the solution easily, just punching it in the calculator. Shift, turn the answer. I can get negative 68.26, and from this I just have to add k plus 180 degrees. This is the general solution. This is the general solution. But the important steps that are what due marks is, are you able to expand this using the compound angle identity? So once I expand it, I get cos 60 is equals to half, and half times 3, I get 3/2. And here, sine 60, I get √3/2 times 3, I get 3√3/2. The next step is to group them now. So because I want to add them together, I got positive 68.26. Let's quickly check. Shift, turn, negative 2.51. I'm getting negative 68.26. Unless if you punched in without a negative, then you must get 68. Let's check if there is no negative. If you don't put a negative, you get 68.226. But if you put a negative, it will give you this. So make sure you do your divisions correctly. Right? So this is important. That is one of the questions that we have done. So it's basically knowing your identities. Do not forget your identities. I'm going to quickly write them down. We have cos A plus or minus B. I'm just writing them is equal to cos A cos B minus and plus. It means what is on top is what is on top. And if you take the bottom side, you take the bottom side. Sine A, sine B. Then we have sine A plus B. It is equal to sine A cos B plus and minus cos A sine B. Then we have tan A plus or minus B is equal to tan A plus or minus tan tan B over 1 minus and plus tan A tan B. Now, if we go to the double angles now, we just have cos with sine 2A is equal to 2 sine A cos A. Then we have cos A, cos 2A, we have 3 of them. We have cos squared A minus sine squared A, which is equal to 2 cos squared A minus 1, or 1 minus 2 sine squared A. The last one is for tan. So tan 2A is equal to 2 tan A over 1 minus tan squared A. Those are your identities. Normally, they are given to you on a formula sheet. But normally, the ones that we must really know is this too, because the third one is not very difficult. So I would encourage you to do your work and be more, because as practice gives you better understanding of the concept. So thank you very much for tuning in today. Until we meet again, these are my Facebook handles you can follow if you have got any questions that you want, and also on our WhatsApp if you have any questions. This will be my last day. Next week you'll be having someone else who will be assisting you. So thank you for tuning in, and thank you for tuning in my lessons. I hope you have a great time, and I wish you well in your learning and eventual examinations. So thank you. Goodbye.